Hi, I'm Jaime from UPV, a member of the 5G MAC, and today I'm going to present a little demonstration of a 5G broadcast streaming that uses a software-defined radio equipment that contains and uses a software implementation of a 5G broadcast transmitter and a 5G broadcast receiver. This is the first demonstration that uses that equipment. That means that this is not commercial one, and the transmitter and receiver are software implementations developed by the 5G MAC Reference Tools Group. The receiver one was developed by the ORS member, and the transmitter one was developed by the UPV member. For the transmitter part, we use, for the software-defined radio equipment, an ETUS USRP N310, and for the receiver part, we used a B210. The main goal here for this demonstration was to show a wireless transmission over the air. In this case, was a non-light of sight path, and the distance between the antennas was around 5 meters. The content that we used for the transmission was a webcam streaming. Here in this image, we can see the actual setup. Here are shown the two PCs. Each one of them contains the software implementation of the transmitter and the receiver. And here are shown the two SDR equipments, the N210 and the B210, and each antennas. These two PCs are connected to the same net, but they are unable to multicast the video over the Ethernet to avoid the reception over the cable. And this is just to make clear that the transmission is over the air. It's a wireless transmission. The MCS that we use here was the MCS16. The carrier spacing was 1.25 kilohertz. And this is 5G broadcast release 14 compliance. The bit rate of the actual content is 1.6 megabits per second. The current stage of develop of the transmitter is an early stage, just because the one that we show here was a modified version of a eNodeB SRS run implementation. That means that we modified and released 9 eNodeB that contains a mixed mode of broadcast and unicast transmission, just to be a release 14 compliance. There is still some issues that we have to address. For example, some PMCH subframes are empty, and that causes that the signal is unstable. And there is a problem because the transmitter power and the spectral power must be the most stable as possible, because the amplification stage in a HPHT transmission needs the input signal, to be the most stable possible to correct the non-linearities effects of the amplification stage. So the next step is to test the transmitter in a HPHT facility, just to test more use cases such as mobile reception while walking, in a vehicle, MIMO, to test the reception while we have two antennas, etc. That was all. Thank you so much for your attention.